In this video, we'll look at how to create a mathematical model of some data using technology, and in this case, we'll use Desmos. So here's my set of data for the time in hours and the amount of snowfall in inches. So it's in a spreadsheet. I'm going to copy that, Control C to copy, and then I'm going to go to Desmos, and I'm lucky enough that I can just paste it in, and you'll see that the data appears here. Get rid of this for now so we can see it. And so now that the data is here, we're going to get Desmos to do what's called a regression analysis for us, and we're going to get it to tell us what the equation of the that represents the data is here. Now, there's a little bit of thinking that has to go on here on your part, and that thinking really is all about looking at this data and saying, well, I think it's linear. So this clearly isn't linear, but let's look at if you thought it was linear. So when you do a regression in Desmos, it's going to look like this. So you type in y1, and the reason y1 is that in this table here's my list of y values. So I'm telling it to look through the y values here, and we're going to say we're going to type in a tilde. So that's shift and the top left corner on your key on your keyboard, and then we'll say mx1. So again, telling it to pick the x1 values from this list over here plus b. So you can see that Desmos goes through and it calculates the line of best fit for us. If this were a straight line, here is the line of best fit, and you can see that it doesn't fit the data particularly well. It tells us here that m is equal to 4.82 and b is equal to -8. So if you think back to the work that you would have done in previous years, we could type in the equation. I'll type f of x instead of y, just so we don't get confused. F of x equals 4.82 x, so that should be a decimal, minus 8. So I've just typed in, I get the exact same equation, but now I can kind of see it there. And again, that maybe isn't the best fit. So let's look at a quadratic function now. Let's see if this is a quadratic function. So again, I'm going to use that y1 tilde, and now I'm going to use a representation of a quadratic function. It doesn't matter which representation, it just needs to be a representation. So I can use that vertex form if I wanted to. So a bracket x1, so x1 telling it to pick from this list of x values, minus h, close the bracket, squared, plus k. And I can see there's the parabola of best fit. And you can see that parabola actually probably fits the data a little bit better. If I turn off the lines, I guess, because I have several of them, especially out here. It's not such a great fit in the beginning, but out after 3, 4, and 5 hours, it's not a bad fit. So I would say that at this point, the line is not a good fit. So let's move on now and compare the parabola to an exponential function. And we kind of said at the beginning that this looks like it might be exponential, so here we go. In order to type this one in, we're going to do y1. I should mention that you don't have to do anything special on your keyboard. You just type y1, and it will put the subscript there for you. There's the tilde, and the exponential form looks like this: a times b to the exponent x. You can get that exponent either by hitting Shift 6 and then typing x1, or if you'd rather, you can click on the arrow on the keyboard and get all of the tools that you might need there. All right, and you can see here the exponential function is in blue. I'm just going to turn off the quadratic so we can see. And we can see that we have a pretty good fit here to our data. The one point that doesn't fit great is this one here, but it's a pretty good fit. So I would say that this is probably a good candidate for an exponential function. And here's the equation. The equation is this will be y equals the a value that it gives us right down here, times the b value, which is here, to the power of x. And let's just type that in here. So we'll call this, we already have a function f, so let's call this g. G of x is equal to, and I'm just going to type in these values that we see here and this equation. So I replace the y's with x's, the y's with y's, or in this case the function notation, the x's with x, and the a and the b will get replaced with these parameters here. So I'll type it in, 0.119882 times b, which is 2.81 231 to the exponent x. And you can see that it does in fact match up. Now you might wonder why would I type in that equation? Well, if you're looking for the equation, you can see it there, and hopefully you can see those parameters, a showing up where the a value was in our original regression, b showing up where the b value was as well. And then the nice thing here is that if I want to know how much snow fell after 3.5 hours, I can just simply type g bracket 3.5. So it remembers that our function g is right here, and it will sub a 3.5 in here for x and tell us that there were 4.47, approximately 4.5 inches of snow at the 3.5 hour mark. Now, if you want to go the other way and figure out what, if you know what a y value is and you want to find an x value, you can do something like, let's say we wanted to say, at what time will there be 30 centimeters? So I'll make a new function here called h. We'll call it h at 30. Oops, we'll put a 0 in there. H of x, pardon me, equals 30 because we want the function to equal 30. And you can see that this has created a line here at a height of 30 inches. And if I want to know what the function value is, you can see that that point of intersection is now there and labeled. So at approximately 5.3 hours, the snow depth will be 30 inches. So that's how we can use Desmos to do a regression, either linear, quadratic, or exponential. How we can use Desmos to evaluate at a certain point. And the last part was just how we can use Desmos to figure out when a function is equal to a certain value.